Welcome, students, to another video lecture with Mr. Kinnett. We're moving on to Chapter 10 in our Glencoe book here, and we're learning about how to compare populations using mathematics in this lesson. So this is going to kind of seem like a science chapter, but we're going to learn how to manipulate our data with our math so that we can compare and contrast populations. So go ahead and pause here and copy down what you see. Okay, welcome back. So this is a double note. We're going to talk about first about the measures of center, and then we'll move on to talk about the measures of variability. And then in our future lessons, we're going to start to learn how to use these skills that we've seen in our past to compare populations. So we're going to use our math to compare populations. So our essential question is clearly, how do we use measures of centers and variability to study populations? So mean. We've all heard mean before. What's that A word that's a synonym for mean? Yeah, you're right. It's average. Average. Okay. And what is a one word that kind of helps with median? If we have our numbers from least to greatest, the median is always the number in the. Yeah, you're right. It's the middle. And then we have mode, and the word that we want to use to remember mode also starts with MO. It's the number that appears the most. And it's important to realize there could be more than one mode. You're allowed to have more than one mode. You only have one median, and there's only one mean. Okay, so we have a problem here. We don't want that just yet, so I'll get rid of that. Okay, so pause here and copy down what you see. Okay, awesome. Welcome back. So our goal in this problem is to find our mean, median, and our mode. These are all measures of center. We're going to try and figure out which one is the best measure of center for this data. So to find the median, you can't just use the numbers the way they're written down. They always have to be written from least to greatest. And to save some time, that's going to look kind of like this. So I like to start with my median because it gets my numbers listed from least to greatest. And the way you find the median is you find the middle. So I'm going to circle numbers so that they don't go away, but I'm looking for the middle. So 1 on the left, 1 on the right, 2 on the left, 2 on the right, 3 on the left, 4 on the right. Wait, this is the middle, but there is no number actually there. So whenever you end up with an even set, that means that the number of numbers in the sequence they give you is even. So in our case, we have 8 numbers in our sequence here. So it's an even set. We have to do a little bit more math. If this ever happens, you're going to have to add the 2 numbers in the middle, and then you divide by 2. So 42 plus 45 is 97. And that is 43.5. So our median for this problem is 43.5. And again, the median is you only have to do this extra math if there is an even number in the set. If there's an odd number in the set, for example, if the set was 1, 2, and 3, we circle 1 on the left, 1 on the right. Oh, the number in the middle is 2. So the median in this sequence would be 2. So again, it only has to do extra math when the median has an even set. So we found the median. Let's also find the mean. To get the mean, we're going to have to add all the numbers in the set. So we have to add 26 plus 38 plus 48 plus 42 plus 45. I'm going to have to move further left or I'm going to run out of room. Plus 50 plus 51 plus 58. And then, remember in our mean, you divide by the number of numbers. And we pointed out from the median, there are 8 numbers in this set. Okay, so we got to add 26 plus 38 plus 48 plus 42 plus 45 plus 50 plus 51 plus 58, and that gets you. Yeah, you thought I was going to give it to you. Go ahead and take this time real fast and start to figure it out. Okay, so giving you a little time to add all those together. What'd you get? How many of you got 358? And we're just following the order of operations right now. So 358 divided by 8. Well, that's going to be some division. And it terminated. Okay, so our mean is 44.75. This equals 44.75. Okay, so math has to usually be done for the median and mean, but the mode, we're just going to look at what number shows up the most. Well, from looking at this, the mode, well, 38 shows up twice and no other number does, so 38 is our mode. If no number repeats, there is no mode, so you don't always get a mode either. But in this sequence, this 8 sequence number or set, we have the number 38 show up twice, so it's our mode. So right, just to review, our median we have is 43.5. Our mean is 44.75. And our mode is 38. Which one best represents the center of our data? Yeah, I'm going to let you keep on pondering that one. And we're going to keep on moving on here. So I'll answer that in class. So now we're on to this slide, measures of variability. Okay, now what we're doing with measures of variability is we're trying to find out how much the data is spread out or really tight together. So thinking of science words for this, density. We're trying to think of how the data is spread out. So I'm going to have you pause here. Actually, right before you do that, I'm going to scroll this down a little. The heading of the table is measures of variability, and that gets the whole table for you. Okay, so go ahead and pause here and copy down what you see. Okay, welcome back. Okay, so range. Again, this is a little bit more math we're going to be doing. All you got to do to find the range is you take the maximum number in a data set and you subtract it by the minimum value in a data set. And that's the range. A quartile. Well, what does the prefix qua represent? Think, how many quarters are in a dollar? How many wheels does a quad have? Yeah, you're right. That stands for 4. So we're going to learn how to break up our data into 4 equal groups. The interquartile range, that'll make more sense once I teach you how to find the upper quartile and how to find the lower quartile. But just like range before, it's just a subtraction problem. And then the outlier math. It's important for scientists to realize when something they have discovered in their data set doesn't really belong. It's just a mess up, and we call those an outlier. And there's a little bit of math we're going to do to find those. So I'm thinking you probably already copied all that data table down. Let's jump a little ahead here. And this table wants us to find the variability. So in order to find the quartiles, that's what you're always going to start with first, is finding the quartiles. Let's actually pause here. I think this is best explained in class. So we're trying to find the quartiles in this next thing. We're going to pause here, copy down what you see here, leave some space, and we're actually going to solve this problem in class. Thanks, students, for another lesson with me. Measures of center I feel like you've seen before, and measures of variability we're going to continue going over in class because these may be new topics to you, and they look really confusing with the words, but once we know what these words mean, the math to figure them out is not too difficult. So again, don't get overwhelmed by the words we're going to be learning here. Once we figure out what the words mean, the math to do is not that hard. If you have any questions, write them in the question columns and then feel free to ask them. Remember, I love when I have questions. You have to copy what you see, but you're always allowed to add more. So I hope to see you in class soon.